Let's take a look at this question, which gets at transformations of exponential functions. So we've been given a graph shown on the screen here of a function, and all we know is that it's a transformation of f of x equals 2 to the x. So this would be considered our base graph, and then the graph that's shown is a transformation. So we need to determine what is the equation of the graph we've been shown. Maybe a good starting point would be to put in the graph of our base function, so that we can better compare and see how it's been shifted left, right, up, down, that kind of thing. Probably just by looking, you can tell maybe there's a right and a down shift to the curve, just based on where it's located in the coordinate plane. But I'll just make a little table of values for the base function. Won't spend too long here, but I know if I plug in -1, 2 to the -1 is the same as 1 over 2, so 1/2. Plug in 0, anything to the power of 0 is 1. Plug in 1, 2 to the first is 2. Plug in 2, 2 squared is 4. So let's just plot those points to get in a nice picture of our base graph. I'll just go one more. 2 cubed is 8. So here's just the base graph. And now we want to decide what's happened to this base graph to get to the original function that was drawn on the screen. And I agree with you, it's not the easiest question. So what helps me a lot with questions like this would be to focus on some main points. So for example, the y-intercept of the base graph. Notice how I move from the y-intercept to the next point. I go up 1 and over 1. Now, of course, exponentials don't have constant slope, so I'm not going to move in the same way from that orange point to the next point on the graph. But can I find a place on the transformed graph where I see that same relationship of moving from a point up 1 over 1? So what I mean by that is, I notice that if I lock in on this point at 1, -1, then I do move up 1 over 1 to get to the next point on that transformed curve. Let's try that same idea again. Let's pick on another point. From the orange point on the base graph, you can see I move up 2 over 1 to get to another clear point on the function. Notice on the transformed graph from the orange point, again, if I move up 2 over 1, I get to a clearly identifiable point on the transformed function. I could even go one more, and then I'll stop here. I could go up by 4 and over by 1 from the green point to get to another clear point on the base function. Similarly, on the transformed function, go up 4, over 1, and we get to a really clear point. So now if I ask myself, how did I get from the red point on the base graph to the red point on the transformed graph? It looks a lot more easy to identify a horizontal shift and a vertical shift. That same shift will exist between the orange points, the green points, and the blue points. So I guess what I'm saying is I approach this problem kind of point by point to make it feel more understandable. So from the red point, do you all agree I went right by 1 and then down by 2? And then notice from the orange point, same thing, right by 1, down by 2. For the green point, right by 1, down by 2. For the blue point, right by 1, down by 2. So definitely what we're saying is that the transformed function needs to shift, we just said right by 1 unit, and we also need to shift down by 2 units. So we need to write an equation that incorporates those two transformations. So how does that seem? Kind of looking at it just point by point. Hopefully that makes this problem feel a little bit more understandable. So we are actually pretty good at writing transformations with horizontal and vertical shifts. So we know that our new equation will look something like 2 to the x plus h plus k, right? Where h is going to be that horizontal shift and k is going to be that vertical shift. So now let's just fill in the numbers that we have for this problem. So we're shifting right by 1. So that actually means we're going to have x minus 1, right? So the horizontal shifting is negative if it's right, positive if it's left. And then down by 2 tells us to subtract 2. A vertical shift will be down if it's negative or up if it's positive. So this is the equation we're looking for in this question. I hope you enjoyed this as one strategy to come up with that equation.